In this application, we have the APA20-80 model right here, and you can see we have it set up looking down at this foam target, and we have a couple white ceramic NIST traceable gauge blocks, and if I cover up the detector, you can see the laser line right there. So here's the foam target. Here's a 5mm and then a 2mm gauge block on top of the 5mm. And the purpose of this is to show you what a good flat surface looks like. And let's go ahead and just check the measurement value. So we're going to put a feature here, and we probably don't need to take that big an average, but let's go ahead and do it. And so what we're going to do is we're going to go into the features section of the Acuity View software, and we're going to measure not the width but the height. And of course we're doing an average, and once again an average on that section. And we do have a nice little feature here that will allow us to, let me just come in here and to create a tear and an offset. So we know that distance is going to be 2mm. So let's just plug that in. And we'll tear it. And so here, let's show this resultant screen a little bit bigger. And let me just pull that up again. A little mouse issue here. So let me just pull that up again. And we don't need it this big. We'll go ahead and shrink it down. So you can see here we have a known distance. We've definitely shown that is correct. And what I have noticed is, looking at this target, we are getting a very good signal off of it. Let me just clear those measurements. So that's the different foam target. It's not giving us, the lasers aren't going way down into the different pores and everything. And let me just zoom this up so you can get an idea. But what I think is probably happening is the laser's probably partially penetrating to a couple 0.3 of a millimeter. As an example, let's just put in this 2mm gauge block. And here you can, of course, you can see the difference in the features. And let's go ahead and add that same measurement feature we had before, where we're going to look at, that's the gauge block surface, and this is the foam surface. And so what we're going to do is we're going to create a bigger area to scan. And let's just change these features once again. We're going to look at the height and Z, and we're going to average over both features. And here you can see that we're getting a little bit difference in measurement, right? So it's showing 2.7. So it's about it's creating a 7/10 offset, showing that it's, that it is from this surface to this surface is further away than it should be. So it is penetrating quite a bit into that surface. So let's go ahead and move the scan a little bit and see if we are seeing that same offset because of that. So let's try a different target. This is a really thin material. And what we'll do is we'll go ahead and just move our feature boxes, and they'll be able to make that measurement. Here we're getting 2.75, right? I mean, this laser is accurate to about 2/1000ths of an inch, which is about 50 microns, right? So we should be doing much better than that. And here's the third piece, material, and we're looking at that, once again, very good surface. I think it's giving a very good representation of it. It's just the laser is penetrating somewhat. And let's just move our blocks again. And here we are getting about 2.7.28. So we definitely can get a surface height on this. And it would probably be possible to create a little tear function where you could, it seems like we're about 0.7 millimeters off. And if we created did some testing and basically came up with what that is, right? I mean, we would tear that again. As an example, let's look at that height. And so here we're at 2 millimeters, and let's just see what the other surfaces are going to do with that same sort of tear. So it seems to be pretty linear. Right there we're at about 2 millimeters on this surface, so it is measuring that, to a known standard from that surface. So it does appear to be pretty linear. And once again, we're right at that 2. So I believe that we could probably calibrate or create that offset to give a good measurement. Hard to tell, as an example, if we're looking at this surface, and let's just clear these measurements. And clear the measurement. So here's the difference between, the surface there, and here's as you can see my finger going across there. I'm not sure what these measurements are, but it would be, I think this is a really good surface for a laser line and not the single point. Single point would definitely would actually go too far into it, and with this, as you can see, we're getting a nice, fairly flat surface that looks pretty pretty representative of the actual surface. And then we start blowing it up. Each of these is about 1 millimeter. So there is an offset, but I think that we should be able to correct for that to make a thickness measurement.